Hey guys! So in this video I wanted to talk about isosceles triangles and go over some properties of their sides as well as their angles. So the main definition of an isosceles triangle is going to be a triangle that has at least two sides that are congruent. And congruent means equal in length or in measure. So for these two triangles, you can see this triangle here has two sides that are congruent. In geometry, the way we indicate two sides that are the same length is by putting a little dash called a tick mark on the sides that we mean to indicate are the same. Another way they can tell you that the sides are the same is literally by just giving you the side lengths. So they could have a triangle like this, and they could say that this side is 7 units and this side is 7 units, and then you would know that that's an isosceles triangle because two of the sides are congruent. Here I have another two sides that are congruent. I'll go ahead and use different tick marks so I'm not trying to say that it's the same length as those, but so this has two tick marks and two tick marks, indicating that these two sides are the same length. Therefore, we can call it an isosceles triangle. So an isosceles triangle will have a few properties that go beyond just kind of the name isosceles and having two sides that are the same. The first thing is the angles that are opposite from those sides are also congruent. So here's this side right here. This is the side. If I go opposite from that side down here, that angle will actually be the same measure as if you look at this side and you go opposite from that one, it'll be the same measure as that. So these two angles will have the same measure and these two sides will have the same length. Same thing here, opposite from the side. So opposite is going to be over here, and I'll use two markings to indicate it's not the same as that. Here I have two markings, so I'm going to go on the opposite side. And so these two angles are going to have the same measure. Same thing here, if I look at my isosceles triangle, I'm going to take the side that is congruent to the other side, and I'm going to go opposite from it. So opposite from it here, I'll use 3 markings, and then to the other side, or the other angle, 3 markings. So the way I usually think about an isosceles triangle is I think of it kind of standing up, like here, where the top, which we call the vertex angle, so the angle that's different from the other two is called the vertex angle. And the other two angles are called the base angles, because we consider the side that is different from the other two the base. So we would call this side, I'll use a different color, we'll call this side the base, and then we call the two sides that are congruent to each other the legs. So in this one, these would be the legs, and this side, the side that's different, would be the base. Same thing here, the side that's different is called the base. The sides that are the same are the legs. And then again, we've got a vertex angle and base angles. Over here we have a vertex angle and a base angle. So what does this mean for you as a student trying to solve geometry problems? I would say probably the most important thing is whenever you're talking about the angles of the isosceles triangle, the problem that you're working on can give you less information than a typical problem if it's an isosceles triangle. You can actually be given even less information if it's a special type of isosceles triangle, which has actually more than two sides that are congruent. If it had all 3 sides that were congruent, it would be called an equilateral triangle. So an equilateral triangle will have all 3 sides that are congruent. It's actually just a special type of isosceles where it has more than 2 angles and 2 sides that are congruent. All 3 sides are congruent, all 3 angles are congruent. So with an I forgot the L there. With an equilateral triangle, they don't have to give you any information about the angles. We automatically know that all three angles in an equilateral triangle are 60 degrees because we know that the three angles of a triangle add up to 180. And so if all three angles add up to 180, and there's three of them, we get 60 degrees for each angle. So in an equilateral triangle, we have 60, 60, 60. So those ones, usually you look at the problem and you think, oh, I don't have enough information to solve this. Just check if it's an equilateral triangle, because then you can automatically put 60 degrees in each corner. For isosceles, they have to tell you a little bit of information, but just not as much as a typical, like a scalene triangle, where all three sides are different. So if I had a problem that had, let's say, an isosceles triangle, and they have to tell me which sides are congruent. So let's say I consider these ones, they kind of look like they're like laying on their side. So if these two sides are congruent, I would know that these two angles opposite from them are congruent. So in a problem, maybe they only give me one of the angles. Let's say they tell you that this angle right here is 55 degrees. Just knowing that one angle, you can solve for the rest of them, because the rule is that if it's opposite from the sides that are congruent, the angles are going to be congruent. So this would also be 55. And then if you add those two together, it would be 110. And we know that we have to have 180 degrees for all three interior angles of a triangle. So we would know that this vertex angle would have to be 70, because we need to get all the way to 180 when we combine all three of them. Similarly, they can give you a problem. Let me just draw one that's standing up. Maybe instead of giving you the base angle, let's say they just give you a vertex angle. So let's say they tell you that this vertex angle here is 40 degrees. My shapes are not drawn to scale. So drawn to scale means if you actually measured the angle itself, it really would be that many degrees. Like if you used a protractor, if I'm just drawing it by hand out here, I'm not drawing it to scale. So this is 40, and I know that these other two, because they're across from the sides that are congruent, I know that this angle has to be the same as that angle. So we know that all three of them have to give you 180 degrees. So if I take out the 40 I've already accounted for, then I know that this 140 has to split between these two, and they're the same. So you can just divide that by 2, and you would get 70 for each of these angles. So that's one way that when you're dealing with isosceles triangles, you want to keep in mind they might not give you, two angles. They only need to give you one angle in an isosceles triangle, and you can find the other two. You're either going to copy it and it'll be, one of them will be the same, and then you can subtract it from 180 to get the vertex angle. Or if they give you the vertex angle, you can subtract that from 180 and then split the difference between the other two angles. So those are angles in regards to isosceles triangles. Now let's talk about the side lengths. So one of the properties, and I'm not going to do a full isosceles triangle theorem proof in this video. I'm not sure if I'll make one. But one of the cool things about an isosceles triangle is, I'm going to draw it standing up, or how I consider it standing up. So these are the two sides that are congruent. Here's your vertex angle, here's your base angles, here's your base, here's your legs. So the really neat thing about an isosceles triangle, and this would also be true for an equilateral triangle, is that if you draw a line exactly down the middle, and you make sure that that line bisects the top angle, bisects the vertex angle. So the word bisect means cuts exactly in half. So if you're sure that this line bisects this vertex angle, so that would mean that this side of the angle, so let's say the top angle was 70. This part would be 35 and that part would be 35. They would be the same. Well, if it bisects that vertex angle, we know for a fact it will intersect the base perpendicularly. So it will form a 90-degree angle with the base. If you want to know why all that works, you can look up Isosceles triangle theorem proof, and you can watch a video on somewhere else on YouTube of someone explaining how that proof works. But what happens is your isosceles triangle is really just two right triangles that are joined together, and they're the same exact right triangle. So this right triangle is the exact same size as this one. There was a problem on Khan Academy that a student asked me to kind of go over. So I'm going to make up my own example that looks similar to the one that they had there and walk through how you can use that. The main thing you want to think of is anytime you see a right triangle, if you're just looking at half of it, a right triangle in your mind should make you think of the Pythagorean theorem, as long as you're talking about the sides of it. So if you have a right triangle, you can do the Pythagorean theorem, but the Pythagorean theorem only works with right triangles. So if I had just to compare and contrast, if I had like a scalene triangle, so maybe like a triangle where all three sides are different, if you try to draw a line down the middle, let's say I bisect that angle right there, it's not going to be perpendicular to the bottom. It's not going to let you copy anything. These two triangles aren't the same. So you can't do Pythagorean theorem with any of this. This is just a unique property for isosceles triangles. So I believe the problem in Khan Academy, again, this is not drawn to scale at all. I think I would need to make this a lot wider, but let's just go with the numbers. So let's say that the length of this diagonal line here, this leg, was the square root of 34. And if that's the square root of 34, if this is isosceles, this one would be the square root of 34. And let's say the height in the middle, this dividing line, this bisector here, let's say that that's 3. And let's say the question asks you for x. You want to be careful as to where the x is located. Here, I put it right in the middle. Now, if you were taking one of my tests or quizzes, I try to be really careful about letting you know what they're representing. So here, this x, by them putting it in the middle, they're trying to show you that it represents the entire base of the whole isosceles triangle. It doesn't just represent like that little part, that base of the right triangle. But they ask you to solve for this base value. So anytime you're solving for a side of a triangle and you have a right triangle, you're using the Pythagorean theorem. So I like to redraw just half of it. So I'm just going to redraw that half there. And this would be 3. And I don't like to be too confusing and call this x divided by 2, although you could. I usually just use another variable like a or b or something. So I'm just going to use the letter b for this part here. But hopefully you can realize if this part is b, this is just like a mirror image right here. It's just like a reflection of another right triangle on the other side. So this would also be b. So once we solve this problem for b, we're going to have to double it or multiply it by 2 to get our final answer that they asked us for. So don't forget to do that step. A lot of times if it's multiple choice, the answer you get whenever you just solve for the base is on the options for your multiple choice answer, because they just want to catch maybe you forgot to do that last step where you multiply it by 2. All right, and let me bring down this square root 34. And then you're just going to do the Pythagorean theorem. Now, if you need help remembering that, I do have a video on Pythagorean theorem, but this is going to be like the second case of the Pythagorean theorem where they gave you the hypotenuse. Remember, the hypotenuse is always opposite from the right angle. Sometimes they won't actually draw in the right angle for the isosceles triangle. They're just going to draw the line down the middle and split the top part, show that it's like a bisected angle, and then you're kind of supposed to know, oh, if it bisects that angle up top, it's actually 90 degrees with the base. And you can just do Pythagorean theorem. I'm going to have this represent A, this represent B, and then this is going to be C because it's the hypotenuse. So I'm going to do A squared, let's do it here, A squared plus B squared equals C squared. So it's going to be 3 squared plus B squared equals Now, these square roots, sometimes you guys get a little bit freaked out by them, but put the square root 34, and then a lot of times you'll use parentheses, and then you're going to square that. So anytime you square a square root, they just cancel each other out. So if you square the square root of 34, you're just going to get 34. And then that would be 9, and that would be b squared. And my next step is to move the 9 to the other side. And I'm going to get that b squared is equal to 25. And then my last step is going to be to square root both sides. So I'm going to end up finding out that that b is actually equal to 5. So this is 5 right here. So when I'm going to solve my final problem, I know that that's 5 and that's 5. So the x they're asking me about is 10. If you're struggling with those, just make sure you feel really confident about the Pythagorean Theorem and doing that, as well as just don't let this part kind of scare you. When you see these square roots, a lot of times you just feel a little bit uncomfortable because maybe off the top of your head you don't know what the square root of 34 is. But I mean, the square root of 36 is 6, and you probably know that. So the square root of 34 is just a little bit less than 6. Maybe it's like, 5.82 or something. But you don't have to think of it as a number. Just know that whenever they put those square roots in the problem, it's probably because at some point in your work, you're going to end up squaring it, and it'll just cancel out, and it'll turn into a very nice problem that will work out numerically. So I hope that that's somewhat helpful. Let me know if you have any specific questions, and I can try to make another video to address those. And I hope you have a great day.